Hey everybody, this is Jared Foster, DCM for the Raleigh Data Center. I wanted to give you a quick look at Ignition, its overview, the principle in which we use it, and some of its functionality and what we're using it for. So, jumping right into it, we start at SharePoint. We click Data Centers, Facilities, and we go to Raleigh. I have saved the link to Ignition so you can never lose it right here on our Raleigh homepage off to the right hand side, as well as some good information as well. So by the time that you are watching this, Jace is probably long gone and will be replaced with Structureware here in the next week or so at the time of this recording. So we'll click Ignition here, and this takes us right to our project. So if you're actually wanting to log in, if you have logins to it, we will launch you in the designer up here. That is out of scope for this tutorial. So we are going to launch our BMS project, and we will launch it right here. We can run this, minimize. All right, for site ops text, it'll be raw-ops, same password. All right, we're here at the home screen. I do want to explain a little bit about the theory of the BMS and what we're trying to accomplish with it. So there's two kinds of BMS philosophies. So there's monitoring and there's controls. Controls meaning it's actually doing some kind of scripting or something to where it's actually controlling the operation of critical infrastructure, whereas a monitoring system just reports that information back through a variety of different protocols. So the purpose of this is kind of a hybrid between the two. So Ignition, primarily we're using it as a monitoring solution with a little bit of control built into it. We do have read and write access to certain points in those protocols. In this case, it's going to be Modbus protocol, to where we can write ones or zeros to things to manipulate the state of infrastructure. Whereas like our chiller systems and things, we're actually going to want to use a true control system, like what formerly Jace was, those Jace controllers, or now our Structureware, our AS, our automation server. So that's what's going to be handling the controls of our chiller systems, our pump speeds, the different sequence of operations there. So hopefully that makes a little bit of sense in why we have two systems, two approaches to kind of the same thing, because they're just different tools to accomplish different jobs. We are offering up the data from our Structureware system and ingesting it into Ignition very soon. So we'll be able to see the same data in both places. It's just more convenient for alerting and seeing it all in one place in Ignition. So this will be our single point to infrastructure. So getting right into it, we have a layout of the facility broken into DC 100, 200, 201, and 300, and then some of the support spaces like E300, and it'll show the gin yards and things like that. So it's advantageous here because you can get a visual layout of where everything is and the state in which it's running. So for example, we're in DC 100 right now. We can see all the crack units that are brought into Ignition, and PDUs, switchgear, UPSs, anything that is being brought into Ignition is visually shown out on the floor. So to navigate some of these, you can click on some of these buttons, and it'll actually give you information. What this information means will be covered later, but it gives you the option. So this is where you'll see different alarms as they come in. Anytime an alarm comes in, it's going to be blinking red. When we get over to DC 300, you'll actually see that because there's some information that's not in there yet, and so it thinks it's an alarm. But everything will be blinking yellow and red, alternating, should we have any issues. So We can click stats on the ATSs. This is super helpful if you ever call me in the middle of the night and say, hey, we just took a power hit. I'm going to say immediately, hey, what are our ATS connected to? Are they connected to normal or emergency? And you can find that information out here. Most likely you'll be up doing a roundabout, but if there's more than one person in the knock, one person could do a walkthrough while the other person's kind of watching the ignition stuff. So it is reliable enough, quick enough that it's going to be able to be used in critical incidents as a visual check, as a reference to see what the facility is doing. Typically, for example, real quick, if we have power bumps or anything of that sort, I generally stay and watch ignition while the technicians actually go out and physically check and verify that everything's in the position that it's supposed to be in. So, provided I don't see anything issues, they don't see anything issues, we just go back and do the proper reporting and notification. Or if we identify something, that's when I can kind of direct people to it and then start heading that way myself, kind of like a command center type idea. Expanding further into that, we have screens, more detailed screens for our crack units. This is where I get into saying we have a little bit of control into the facility, because we can actually turn units off and on the mechanical side from these screens. And in order to do that, you would literally just click here and say yes or no. Would we want to turn this crack on or off? Yes. We don't want to do that right now, but that's the example. So you do have a little bit of power in here, so we trust that, if you're on the team, you're not going to be clicking around and turning units off and things like that. It's just a critical part of being the team. We trust that you're not going to be altering the state of the data center accidentally. Also why we shoot this training video, to ensure that nobody accidentally does things like that. Moving on to 200-201, much of the same thing, floor layouts. This was kind of my test bed, so there is quite a bit of more functionality. We do have rotating units. We have scripts that we can run to rotate these units every Monday or whenever we choose, as well as PDUs on the screen and some more detailed information here. So for 201, we have our crack summary. Right now we have an alarm right here on crack 30 saying high return air temperature. So his return air is at 81.1, which I just know that 80 degrees is the alarm threshold, is why that's going into alarm right now. Not overly critical, as I can see the other two units in this space are doing quite well. 30 I know has a known condensate issue, so that's why it's probably given this alarm. And oh, that's interesting, there's no compressors running on this one either, so not super alarming at this point, provided the temperatures hold. We have our PDU summaries, where we can monitor the status of our static transfer switches that are in this space, as well as our BCMs. So provided everything is good, it's going to be nice and gray. Whereas if we had different operating conditions, we would actually see red blinking here. We'd see common alarms and preferred sources and things. Our crack summary is probably the most involved. I designed this screen to show what source it's being fed from. So if it's blue or gray, this is a unit, this is a B unit, as well as the controls. So I can just show you right now. If you click off, it's going to say BMS control. It's saying it's off and the unit is stopped. So if we want to start it, we just say yes. And here you can see this number right here, just read blocked out for a minute. And this number dynamically updated based on how much running is in the space. So let's go look at 222 and make sure that it turned on. 222 right here is running now. We can go back and say, no, we don't want you to run. And immediately 222 says, I am off now. So that's about as much control as we get into the cracks here. And of course, we can rotate the running units. This script is written to where it'll run all of them for 5 minutes and then shut off the ones that ran. So also important, if we have any kind of emergency in 200, we have an issue where certain crack units are off, provided failures or anything like that. If our running unit capacity dips below the cooling required, it automatically turns on all the units. So that's slick, really protecting us from putting too much load in the space, or if units fail and we don't have time to react, there's a little bit of automation that, hey, it detects I can't cover the room, there's too much heat load in the room, I'm going to go ahead and kick on everything to try and kick everything on to get the sufficient amount of cooling, and then we can go manually investigate and manually turn off units as we need. Or there is this safety switch. If we know there's an issue before the software does, we can just go ahead and hit on, and it'll kick on every unit in this space. Also important, if you're trying to troubleshoot issues, we have links to our run book here, which takes you straight to the HVAC folder, and we have different information that we can pull up in here. As well as I like to put in the user manuals. So we have the user manual of these units that are in this space right here in BMS. Very slick. Very much the same thing in DC 300, a lot more going on, a lot more PDUs, a lot more units. Since the screens are very full, I divided the room into 3 sections. So we have zone 1, which is this dividing line right here. Zone 2 is the rest of the units in here, and then zone 3. Very soon we will have control whether or not we want to turn these units on or off. Quick side note, if these units are off, chances are the water valves under the floor are off as well. So in a really bad situation, we may actually have to physically turn on the water to these units. That's kind of out of the scope here. This space has temperature sensors in it. So anything that's blue, we're monitoring the underfloor temperature. So that's the air leaving the floor into the server intake, which is very low right now. We are in process of fixing all of that. This is above floor. These are above floor right now as well. So these are kind of the ones that we've messed with and have it out, and it's working beautifully. It's working beautifully. With this data, we can actually start controlling units. If we start saying, hey, I could write a script saying, if this temperature reaches 70, kick on 62, or 61. Issue a command to both these units. Once we have the data in here, the possibilities are limitless. If you can dream it up and you can write a script, you can get the space to do that. So I could average all these temperatures together and say, hey, if we ever get above 80 on any of these temperatures on the intake side or in the floor, kick on every unit in the space, or a multitude of different things, different scenarios. If you can dream it, you can do it. And this is our E300 space, and we have stats for UPSs in here, which looks like everything is going great. As you can see, we have a nice work in progress here. As well as here. So these units do have an alarm. We don't have a summary page yet for all of these units to see what it is at this time, but I know it's a sensor failure due to another project that we've had. These sensors just think it's bad, which they're not. We just need to reset those units. So our temperatures to the UPS rooms are mounted right here. So we're looking at changing how we're operating these cracks soon, so we don't have 55-degree temperatures in our UPS rooms. That UPSs just don't like running that cold. It's not good for the batteries or anything of that nature. As well as these, and we have our generators. Our generator information is here. So every time we do a gen test, I pull this up and I can watch the status of the generator, make sure it's at the right frequency, right voltage, and what else do I look at? And oh, I guess that's it. Voltage and frequency is the main thing to connect into the building. Very nice, very good information. We will be rolling out one line, so instead of a graphical representation, in a failure situation, utility or something, we could actually pull this up and look a little bit more helpful from this standpoint, making sure that everything is working as it should. And now one of the most important things that you will interact with is the alarming. So anytime there is an alarm, it will show up red. It will have a state in which it's either active or acknowledged or unacknowledged. So anytime an alarm comes in, we should email saying what the alarm is and respond accordingly. Say, hey, this is what I'm doing to help rectify the situation. And then once those alarms come in, you can click it, highlight it, and then acknowledge it. Once you actually acknowledge it, it's going to say and have a notes field where you actually have to fill that out. I'm scanning through here. And we're just scrolling through alarms here, but they can see that they're cleared and acknowledged. So somebody did acknowledge those alarms. There is currently no unacknowledged alarms, and you can sort if there's a lot of alarms by any of these different criteria. So I want to sort if it's active and acknowledged, so I can see all my alarms and what we're doing with those. So that's a high level overview. I plan on doing a few more in how to diagnose certain issues with utility or UPSs and different things in the future. But that's what we've got for now. So thanks for watching. I hope this is helpful. And I'm always open to any kind of feedback if we need certain courses or anything. Always open to exploring those and sharing what I know with anybody. Thanks for watching.